let's take a look at this item here. And if you remember, this is all that they ask you to do, right? This is what I ask you, or I change it up and I ask you this three item. And I want to point out to you guys that they will only ask you this three item. It's either to the left, to the right, or in between. Okay. So again, I type up this item here. You will see that all this problem, they ask you the same thing. And I purposely make this thing here the same. So let's attack this thing here one at a time. So yesterday, or on last time before I let you guys go, I asked you guys, or this is what I mentioned to you guys. If we're looking for A, if we look at A, this is what they ask you is find the area underneath the normal curve for the following. And A, they ask you to find the area to the left of the z-score of 2.10. So how do we find the area to the left, right? This is what I mentioned is whenever they ask you to find the area, you want to sketch your normal distribution curve, right? You want to sketch, and it does not have to be perfect. This is what you want to do is you want to draw this normal distribution curve. And again, because they ask you to the left, just basically you draw this item here. Everybody see that this is my boundary, and this is the area I'm looking for. I'm looking for the area to the left of whatever this z-score is. What is this z-score? This z-score is 2.10. So again, this is what I mentioned to you guys. My advice for you guys is sketch this normal distribution curve. It does not have to be perfect. It does not have to be nice. It's just give you an idea of what side of the z-score I'm looking for. And in this case, do you agree that this is what I have? My number, my z-score is 2.1. So my 2.1 is somewhere right here, and I'm looking for the area to the left, which is any number to the left or any item to the left of this 2.1 is the area to the left. Everybody see that? And now what do I do, or what do we need to do? I told you guys that the area to the left, life is good. Why? Because the answer is in your table. All we need to do, and this table will be presented to you guys on your final exam, on your test, which is this table here. Where do we do? What do we do? Well, we're looking for the z of 2.1. So where's my z of 2.1? Do you see that my z 2.1 is right here? And whatever this area is, 0.9821, whatever that area is the area to the left. Meaning in this case, the area to the left from here to here is 0.9821. So my answer for A, all I have to tell you, or all you need to do is say 0.9821. And that is your answer for the area to the left. And if they ask you for the percentage, if they, instead of say the area and they say the percentage, remember the percentage, all you need to do is remove the decimal 2 places, and that is why, or this is how we have 98.21%. So again, depending on which one they ask you, if they ask you for the area, then you give them the decimal. If they ask you for the percentage, then you give them the percent. Okay, so the area to the left, like I mentioned, the area to the left, life is good, right? Now, what happens if they ask you for the area to the right? So for B, the area to the right, if they ask you for the area to the right, like I mentioned, this is all we need to do is, first of all, sketch your normal distribution curve. Again, I won't grade you on your sketching, so don't grade on mine, right? And again, the sketching part is just basically tell you that what side this is. Again, doesn't matter where you draw your line is. And again, my line, to make it a little bit realistic, my line somewhere on the left of 0 because it's negative. And do you agree that this is the area they ask you to find? they ask you to find the area to the right of this item here, right? So again, the area to the left, we draw a line, we shade it to the left. The area to the right, we draw a line, we shade it. Whatever it is, I'm looking for the area to the right. So the area to the right, we are in a little bit trouble, right? Not really much trouble. Not that big of a trouble. Why? Because if you're looking for this negative, if you're looking for this negative 0.0, negative 0.545, that's where my negative 0.45 is. And if you're looking for this thing here, they tell us that the corresponding area is 0.3264. What is that 0.2364, ladies and gentlemen? A reminder, the 0.3264 is from the left-hand side to here. The left-hand side to that item is 3264. So if you remember, what do we do? If the table tells us that the area is to the left, and I'm looking for the area to the right, well, this is what I told you guys, that if we're looking for the area to the right, if we're looking for an area to the right, we need to take 1 minus the area to the left. We need to take 1 minus this item. And if you take 1 minus this item, you will see that this thing will give you 6376, right? If you take 1 minus this item, you can see that the area to the right is 0.6736, right? If you take 1 minus 0.3264, this is what we have. And that is what we mentioned, or that's why I mentioned to you guys yesterday, that if you're looking for the area to the right, you will always take 1, which is the total percentage, the total item. You take 1 minus whatever the value on the table, right? So everybody see that the area to the left, life is good. The answer is in your table. If they ask you for the area to the right, then we have to take 1 minus that. So question with the area to the left and the area to the right. Now, the area in between a little bit different, right? The area in between here, how do we find the area in between? Well, to find the area in between, this is what you want to do for C. Again, like I mentioned, sketch your item. And again, do you agree that area in between, let me change the color. Let me use black. Green is kind of, the area in between, do you agree that this is what we're looking for? Is anything in between this 2 number is the area in between, right? And what is the 2 number they ask us? Well, the 2 number they ask us is negative. Reminder, a negative number is on the left, and the positive 1.2, which is we're looking for the area in between these 2 number, negative 0.5 and a positive 1.2. So how do I find this area in between? Well, first of all, let's take a look at this item here. Let me use yellow. So where is my negative 0.50? Do you agree that negative 0.50 is right here? And the corresponding area is from here to here is 0.3085. That's where my number came from. And then I need to look for this number. Where is my 1.2? 1.2 is here. 1.2, the z-score 1.2, and the corresponding area is 8849. So 8849 49 tell me that from here to here is 0.8849. So if you look at this thing here, if I mentioned this yesterday, is if you look at the yellow item, the left 0.8 side, and you go all the way is 0.8840. Looking for just this item here. We're not looking for the whole thing here. We're only looking for this portion in the middle. We're only looking for this portion in the middle. So everybody see that in order for us to looking for this portion in the middle, all I need to do is take the bigger value. My bigger value is 0.8849 minus the lower value, which is 3085. I can find the difference between, right? If I know that the long way is 88 and the short way is 30, do you agree that the leftover, the in between those will be 50, right? So in the same token, this is what we do is we just take the longer item, the longer number, minus the smaller item, which is in this case, we have 4. We subtract this, we give 6, 7, 5. So in this case, the area between these two numbers is 0.5764. Okay, so that is the idea. And this, ladies and gentlemen, this is the only 4 questions that they will ask you. They will ask you the area to the left, they will ask you the area to the right, and they will ask you the area in between two numbers. So area to the left, life is good. The answer is in your chart. The area to the right, a little bit shaky, but it's not that bad. You just take 1 minus whatever in the chart. And the area in between is a little bit more item to do. But all you need to do is take the higher percentage or the higher, bigger area minus the smaller area to find the area in between. So let's try another one, and then I take your question. If you have question, let's take a look at this thing here. Similarly is, again, I wrote the same thing, I just changed in the number, right? So if you look at this item, let's take a look at the blue item here. They ask us for the area to the left of -1. And hopefully this is what you guys to, this is what I advise you guys to do is we say, well, let me sketch my normal distribution. Doesn't matter what I have. Again, you don't have to be precise, right? You can put the line right here and you can shade it to the right if you want to, right? But again, realistically, it's not correct, but it doesn't matter. It's just this thing here, just give you an idea. This thing here just give you an idea that, again, my line is somewhere here and I'm looking for the area, sorry. We're looking for the area to the left, right? Sorry. We're looking for the area to the left. And as you can see, that's why you need to sketch, right? I did not do that on purpose. But again, this is why you need to sketch, right? Because we're looking for the area to the left, we know that we need to shade it to the left, right? So, and that's the idea that I want to point out, that you want to sketch so that it's give you the idea of what is the area we're looking for. The area we're looking for is the area to the left, and that's why we shaded to the left. And this is the z-score of -0.1, right? And again, hopefully you guys say area to the left, life is good. How good is that? All we need to do is looking for 0.1, and 0.1 is right here. Reminder, is not -1.0, but it's -0.1. right? It's not the 1.0, but it's the 0.1. So this is what we have. And as you can see, all we have is the area. All we need to do is extract out the area, and the area is 0.4602. And that is your answer, ladies and gentlemen, if they ask you for the area to the left. Everybody see that area to the left of this -0.1 1. The area to the left is 4602. So that is the area I'm looking for, and that is my answer. And that's why I asked you to sketch it. And as you can see, I make a mistake earlier. I shaded on the wrong side. And you need to do, if you shade it to the right, you know that anything to the right, we have to take 1 minus the answer on the chart. So if you shade it to the left, the answer is in your chart. Okay, so if you're looking for B, and again, B, same thing go B, they ask you for the area to the right. And again, this is why you sketch or digital curve. And again, it doesn't have to be nice. If you can draw a nice one, it's good, right? Again, this is all we're looking for, is we're looking for the item on the right of this thing here. What is this thing that we're looking at? We're looking at 1.50. That's what we're looking here, not negative. We're looking for 1.50. So if we're looking for 1.50 and we're looking for the item to the right, we should have an idea that, hey, guys, oh, wait a minute. Because I'm looking for the item to the right, I need to take 1 minus something. What do I need to minus? Well, how do I find this item 1.5? Do you agree that 1.5 is right here? And the area corresponding to 1.5 is 0.9332. So 0.9332, reminder, 0.9332 is from the left-hand side to this right here. And that's why I put a color-coded, because the 0.9332 is from the left-hand side to that value. Am I looking for the red item? Well, no, right? I'm looking for the blue item, the shaded item. So in order to do this, I need to take 1 minus 0.9332. And if I take 1 minus this, I can see that the answer will be 0.8660. Right, so the answer, if I take 1 minus this, I will have 0.0668. Sorry for the mess here, but again, the answer we're looking for, if you take 1, and again, you have your calculator, you can do it in the sense that this thing here, 0.0668. Okay, so again, question here in terms of how to find the area to the right of the given z-score. And lastly, to do this thing here, let me use black so that we have a different color. If we use C, if we're looking for C, they ask you to find the area in between. Again, area in between -1.5 and 1. So area in between, we know that all we need to do is, let me sketch again. It doesn't have to be precise. It's just give us the estimate of -1.50 and 1.00, right? So everybody see that this is what they asked me. They asked me to find an area in between -1.5, and 1.00, right? So how do I find the area in between? Reminder, to find the area in between, the first thing I need to do is I need to ask myself, where is my -1.5? -1.5 is right here. And -1.5 is from here to here. From the area to the left to that number is 0.0668. And then my item from this number to 1. Where is my 1? My 1 is right here. My 1 is 0.8413, right? So what do I do with those two numbers? Well, if I know that the blue from the left all the way to here is 0.8413, and the short distance, the red, is 0.0668, If I know that the long distance is 8413 and the short distance is 0668, all I need to do is take the long distance minus the short distance. And if I minus that, this is what will give me is I will have 5, 4, 7, 7. I should have, meaning the area between two number, between the two value is 0.7740. Okay, again, that's what we have, or that's what we need to do in this problem here. Again, math, because I kind of do on the fly, so my math might be a little bit off if I happen to make a mistake. But again, you have your calculator, you can check my answer there. But question of how to find this area to the left, area to the right, and area in between. And this is all that is, ladies and gentlemen, this is that all that is in find using this standard normal distribution table to find the area or to find the probability. So let's try one more just to be on the safe side, right? Let's try one more. And again, similarly, right? Similarly, and again, it's pretty much the same, exactly the same. The only thing changing is the z-score, right? If you look at this thing here, I just copy and paste everything is just that I changing the z-score. Instead of negative last time, we have a positive 1 point or positive 0.15. So if you look at this thing here, if you saw this problem A, what do we need to do? Well, sketch your item, right? Sketch your item. And again, just if you want to, you can put it right here. It doesn't matter. We know that is my Z, and this is the area I'm looking for. I'm looking for the area to the left of the Z. Everybody agree on that? I'm looking for the area to the left of Z, and area to the left, life is good. Why? Because the answer is on your table. All you need to do is identify 0.15 on your table, and whatever the area is, that is your answer. In this case, 0.5596, and our answer is just our answer is 0.5596. So everybody question with this area to the left. Now, hopefully you don't have question because it's very straightforward in terms of area to the left. The area to the right, and again, if I were to sketch this thing here, as you can see, my normal distribution is not that nicely sketched, but we don't really need to know. And again, doesn't matter where you put the number, and this is basically is wrong, as you will see, but we don't really care about this number here. All we care about is what size that we're looking for the area of, right? We're looking for the area to the right. And because I'm looking for area to the right, everybody see why I say this graph is technically is not correct. The reason is, if you remember, in the middle is 0, right? In the middle is 0. And if it's a positive 0.75, have to be on the right of 0, right? So that's why technically is not correct. But again, you know, we don't really need to be correct in terms of sketching. This thing just give us an idea that if I find the area to the left, the answer is in my table. If I'm finding area on the right, if I find this area on the right, I need to take 1 minus the area. And that's what the graph tell me to do. If it's to the left, the answer is in the table. To the right, I need to take 1 minus that. So 1 minus what? Well, I need to take not the 0.75, but I need to go into this item here, 0.75 is here, 7734. So I need to take 1 minus 0.7734, right? I need to take 1 minus 0.7734. And if I minus that, my answer will be 0.2266, right? 0.00001, right? So the area on the right of this number will be 0.2266. And again, that's what we need to do in this particular problem, because I'm looking for the area to the right. I need to take 1 minus that area. And lastly, area to left easy, area to the right, we need to take 1 minus that. The area in between for C, the area in between, what do I need to do? Well, I need to know that the two number, and I'm looking for the area in between, right? So again, I need to take the bigger area minus the smaller area. So what do I have here? I have 0.5 and 2.20, the big number on the right, the smaller number on the left. And again, I know some of you guys could critique my sketching and say that this sketching is not technically correct, but we not really care about, again, the sketch is tell you that we need to looking for this area, right? So how do I looking for this area? Well, the first thing I need to do is I need to find where is my 0.05 and where is my 2.2. So everybody see that my 0.05, let me zoom in, my 0.05 is this number, and my 2.2 is this number, meaning I need to take the big number, which is 0.9861 minus 0.6915. I need to take the bigger area, the larger area from here to here is 9861 minus the smaller area, which is 0.6915. So if I subtract this thing out, you should see that this is what I have is 6492, right? So the area in between, this item here, the area in between this two number is 2946. Okay, so looking at this thing here, again, that is, in the nutshell, this is what we have. Ladies and gentlemen, question with this thing here, ladies and gentlemen. So everybody know how to find the area to the left, everybody know how to find the area to the right, and everybody know how to find the area in between. All right, I take your word for it, or silence is accepted. I will take your silence. Now, let's take a look at the last item we have. So this is where we come in, or this is where we got to, is 11.7, the last section, the last chapter we have. So what is 11.7? So one thing, if you remember, or what we have earlier, is we need to find the area to the left of some number. We need to a z number. We need to find the area to the right of the z number, and we need to find the area in between. So in chapter 11, or last section of this class is 11.5, is now we need to apply that rule to our application problem, to our real life situation. And again, to do this thing here, this is what you need to do, is to solve the application problem. The first thing, just like before, I want you guys to do is sketch your normal distribution curve. Shaded, the region that they ask you is either to the left, to the right, and in between. The reason why you shade it, is to tell you, mentally tell you, do I just look at the answer from the table? Or do I take 1 minus the answer in the table? Or do I take the two number and subtract them? And that's what the left, the right, and in between tell you. After you sketch it, here come a new thing that you will see is they do not give you the z-score. The table that we have is the z-score. They don't give you the z-score. They will give you some data. The one thing that we need to do is now we need to convert your data to become a z-score. And the data, if you want to find a z-score, is basically z is equal to the data minus the mean divided by the standard deviation. And after that, you will locate the number of the z-score on your table, and then ask yourself, do we have the answer from the table? Or do we have to take 1 minus the area? Or do we have to take the higher area minus the low area, which is the same item we have? And then afterward, you interpret. So let's take a look at this problem here, right? After I mentioned to you guys, I say there's only ask you to the left, to the right, in between. And now here come the problem, ladies and gentlemen. Here come your last set of item. Your last set of item is they will give you the wording, and this is what you need to translate to. They don't tell you the left, they don't tell you the right. They do tell you in between. There's no sugar code between in between, right? Between is just between. So one thing that you have to correlate is if anything less than something, how can we know if it's less than something? Well, anything to the left of that number will be less than that number, right? So if they ask you for less than or below, then that's the area to the left. If they ask you for greater than, more than, or above, those are the items to the right, okay? So if you look at this example, they say if the weight of the Oreo cookie in this package are normally distributed, it's basically tell you that it's a bell-shaped curve with the mean of 518 grams and the standard deviation of 4 grams, find the following. Find the percentage of the package that will weigh less than 510 grams. So how do we find that? Let's attack A. And hopefully this is what you want, or this is the purpose of me showing you the previous to the left, to the right, and in between is the same idea as this thing here. How do we find less than something? Well, the first thing we want to do is we want to sketch our normal distribution curve, right? And again, this is why I type it up, because the normal distribution curve is nicer this way. And if you look at this item here, how do you agree that 510 is some here, right? That's my 510. And if I want to find the percentage of the item less than 510, do you agree that this is the item that I'm looking for? Anything to the left of 510 is less than 510. 509 is on the left side, 500 is on the left side. Anything less than 510, meaning anything to the left of 510 is less than 510. So one thing, if you remember on Tuesday, I told you that if they ask you for the area, if they ask you for the percentage, if they ask you for the probability, it's the same question. This question is the same as find the area to the left of 510. And if you look at this thing here, you say, wait a minute, Mr. Tran, the previous table, there's no 510. And yes, the previous table does not give you the gram. The previous table gives you the z-score. So in order for you to correlate, or in order for you to find utilize your table, you need to convert the 510 to become a z-score. So to convert this thing here, if you remember previously, let's go back. If you remember, this is how you convert the z-score. The data minus the mean divided by the standard deviation. That's your formula for the z-score, ladies and gentlemen. The data minus the mean divided by the standard deviation. So how do we convert? If you go back to our problem, you can see that this is what they give us, is they give us the mean. They give us the mean, 518. They give us the standard deviation. Now we need to know the data. What is the data? The data is the 510. Again, the data is equal to 510. If I plug into my z-score formula, the data minus the mean divided by the standard deviation, I have 510 minus 518 divided by 2. That will give me a -2. And now we got it, ladies and gentlemen. We got the -2. And if you look at the table, I don't have the table in this slide, but if you were to looking for your table, -2, this is the -2 number. And the corresponding area is 0.0228. So is this your answer? Hopefully you guys say yes, because the area to the left is the area from the table, or the percentage to left is the percentage on the table. So all we need to do is convert this decimal to the percentage and interpret your solution. The solution would be, there will be 2.28% of the oil package weigh less than 510 grams. Okay, so again, let's do B. B, they ask you for more than, right? So how do we do more than? Again, how does the more than item? The first thing as the same, we want to sketch this item here. My 528 will be somewhere here, and more than, anything to the right of this number is more than this number. 529 is on the right of 528. 550 is on the right of 528, right? So what is the percentage of package is weight more than 528? We're looking for the area to the right, and this should give you an idea that whatever the area we're looking at, we need to take 1 minus that, because the area they give us is the area to the left. So if you do this thing here, before we do all of that, that area, that table, this is what we need to do, is we need to convert my data. Because if I look at the table does not give me 528. I need to take this data and convert to the z-score. The data minus the mean divided by the standard deviation, the data is 528 minus 518. That will give me 10. 10 divided by 2 will give me 2.5, positive 2.5. And if I look at the table, 2.5, which is 2.50, the corresponding is 0.9938. Is that my answer? Hopefully you say no. No, because we're looking for the area to the right, and the area to the right, we need to take 1 minus the area in the table. And again, you can see that my sketching is not technically, it's not correct, right? Because looking at this thing here, you can see that it's less than 1%, right? Meaning, to be technically correct is like somewhere like this, right? That is where you're shaded. But I don't want to shade it like small like this, and you say, wait, what area we're looking for? And that's what the sketching is, right? We just need to have an idea that we're looking for the area to the right. It doesn't have to be precise, right? It doesn't have to be this precise. It just gives you the idea that we're looking for the area to the right, and the area to the right, we need to take 1 minus the answer in your table. And lastly, for C, if we're looking for the area in between, and again, we sketch our item, we're looking for the area in between. This is the between area, right? It doesn't have to be exactly, persistently, in terms of this. We just need to know an idea. And if we know that we're looking for the area in between, then this tell me that I need to find the lower number, the upper number, and then I need to subtract the 2 areas between those. But before we do that, this is what we need to do, is we need to convert the z-score for the 514, and we need to convert the z-score for the 520. So the z-score for 514 is, again, 514 minus 518, that's your mean, divided by 4 to give you a -1. The table is -1 is equal to 0.1580, 7. And then we need to convert the z-score for 520. 520 is 2 because 520 minus 518 is 2 over 4. 2 over 4 is become 1/2, which is 0.5. And the table for 0.5 is 0.6915. What do I do with this 2 number? What do I do with this 2 area? Reminder, because we find the area in between, we need to take this 2 area and subtract them. And if we take this 2 area and subtract them, this is what I have is 0.6915 minus 0.1587. I will have 0.5328, meaning there are 53.28% of the oil package will be between this weight. It might be 514.7 or 517 or 519. It will be between this. There are 53%, 53.28% to be exact. Okay, so first of all, question. The only thing new, hopefully you guys say, you say, wow, that's a lot of information. But the only thing new, believe it or not, ladies and gentlemen, the only thing new is you need to plug into this formula, this Z formula, because the problem they give you does not have a Z, right? You know, if we were to connect this to the previous problem that we did in the beginning of class, this question they ask you is find the percentage of the data between the z-score of -1 and the z-score of 0.5. That's what they ask you. Find the area, find the percentage of the item between the negative z-score of -1 and the z-score of -0.5. So that's what you need to kind of correlate, right? Correlate this item to the previous problem. And there's nothing else they will ask you, ladies and gentlemen. They only ask you the area to the left, the area to the right, and the area in between. Again, more than will be the area to the right, less than will be the area to the left, and in between there's no sugar coating. In between, it's just in between. Okay, so again, looking at this thing here, let's attack this problem and see if we have, and again, I think I typed all 3 of them up here for you guys to see. So before we look at the problem, right, before we look at the problem, let's take a look at the information they give us, right? What information, what data do they give us? So they say, according to the salary.com, the mean salary for a high school teacher in the United States in the year 2017 was $58,089 with the standard deviation of 15,100. Assume the variable is normally distributed. Find the probability of a random selected teacher. So again, as you see, you say, Mr. Tran, are you throwing the curveball at us? What is the probability? Reminder, probability, percentage, and the area is the same idea, the same item. It's different, but to do it is you doing the same thing. So even though they say find a probability, is the same as find the area underneath the curve, is the same as find a percentage. It's just probability, you give them the decimal. Okay, so looking at this thing here, what data do they give us? Do you agree that they give us the mean? They give us the mean salary of 58,089, and they give us the standard deviation of 15,100. That's very important because that is the 2 things we need to do this item. Ooh. So now let's take a look at A, right? A, they ask you find the probability that the teacher earned more than 77,719. So what do we do? Well, sketch your item. Do you agree that more than anything bigger than 77,719 is on the right-hand side, meaning anything bigger than this is more than this, right? So more than meaning we're looking for the area to the right of 77 32,719. Before we can find the area, this is what we need to do is we need to convert the z-score. We got the data, ladies and gentlemen. The question is your data. We have the mean 5889. We have the standard deviation 15,100. And if you type this thing in, and this is your z-score is 1.3, right? So again, whoever make 77,719, you are above the mean 1.3 space. That's the z-score, right? But again, we're not looking for a z-score. We're looking for the percentage or the area, or in this case, we're looking for the probability. So how do we find the probability? Well, we go in and look at our table, the table that we have in the beginning. We identify that the z is equal to 1.3. That is my z. Now, what do I do with this number here? Do you agree that we're looking for the item on the right? And if we're looking for the item on the right, what do we need to do? Well, if we're looking for the item on the right, we cannot just say, that's my answer. We're looking for an item on the right. We need to take 1 minus that area. So in this case, this is what your interpretation is. The interpretation is the probability of the teacher earn more than $77,719 is 0.0968. That's it. Because that's your probability. If they ask you the percentage, then you say 9.68%. You have to move the decimal 2 places. But again, because they ask you for probability is the same as the area, which is the decimal. So the probability of teacher to earn more than this is less than 10%, right? 0.0968. Okay. So again, question here in terms of part A. Again, I agree with you guys. If you guys say, oh, Mr. Schran, this thing here does not look anything like the thing we did in the beginning where we find the area to the left, where we find the area to the right, where we find the area in between. Yes, the question they ask you is not the same, but you have to relate it. You have to force yourself to think it's the same. And it is the same. The only thing is we need to convert. You need to find a z. That's the only thing is they don't, life is not so straightforward. There's some narrow path. There's some path that you have to take a detour, right? So this thing here, we need to take one detour. And the detour is we need to convert our problem to have a z score. So same thing go for B. For B, find the percent of teacher earn less than. Again, what is the less than? The less than is anything to the left of 32, right? Anything to the left of 32,000, and that's where I belong, right? I make less than 32,000. Just kidding. But again, anything to the left smaller than 32,400 is the item to the left of that. So we know that, if we sketch this, we know that, hey, life is good here, guys, because if we can find the z-score, the area in the table is your answer. So this is the only detour that we need to make. The detour that we need to make is we need to take this number and convert to the z-score. We need to take 32,419, subtract the mean, which is 5889, divide by the standard deviation, which is 15,100. And again, if you divide this, you should expect that this is a negative number, right? If you take this, you subtract, you have a negative 25,670, divide by 15,100. If you divide that, you have a negative 1.7. We are not done because this is not your probability, because remember, your probability is between 0 and 1. We need to look at our table, and our table negative 1.7 is this, and the area is 0.0446. What does this mean? This is what you have is the probability of teacher earn less than, the probability of the high school teacher earn less than 32,419 is 0.0446, which is, less than 5%. Based on this data, less than 5%. But there are still some people, right, And I think that's where most of the Louisiana teacher is, right? This thing here, the survey is for the whole United States. For the Louisiana, the high school teacher make probably around 30,000 to 36,000, right? So again, that's where we are, right? We are in that 5%. We are in that the probability of 0.0446. Okay, so looking at this thing here, question with A, well, A is disappear. Question with B, because we try to find an area to the left, which is less than some value, is the area to the left. And because of the area to the left, we will just take the area from the table. But the small detour is we need to find a z-score. So lastly, this thing here, there's no sugar coating, right? There's no sugar coating of this thing here. We're looking for the area in between. And in between, the only detour we need to do is we need to convert each of the item. We need to convert each of the item to become a z-score. So to find this thing here, we have this z-score on the first item, we have a negative 2.2, and the second item we have 1.6. And if we look at this thing here, my negative 2.2 is 0.0139, and my 1.6 is 0.9452. What do I do with this two number? What do I do with this 2 percentage or 2 area? Reminder, because we're looking for in between, we need to take this 2 number and we need to take the larger area minus the smaller area. And if you take 0.9452 minus 0.0139, you will get 0.9319, meaning there are the probability of the teacher. If you go in and select one high school teacher, the probability of that high school teacher salary is between 24,000 and 82,000 to be short, is 0.9313, meaning roughly 93% of the teacher will be between those salary. We don't know if it's in the low range of the 25,000 or in the high range of the 81,000, but it will be in that range between the 24 and the 82. Okay, so again, if you go Louisiana and you select a high school student teacher, they might be in the low range, with maybe around 30, 35. If you go to New York or Texas or somewhere that is higher, then it might be in the 75 range or in the 80 range, right? So again, but the probability of you select one teacher and they get paid in this range is 93 or 0.9313. Okay, so question here, ladies and gentlemen, question with how to find the probability or how to find the area or how to relate this wording, this application, this real life situation to our normal distribution table. So let's take a look at the last problem, and that's a good item, good stopping point. Let's take a look at this thing here, and again, hopefully you guys see that yes, they scramble them around, but they still ask you in between. They still ask you less than, which is on the left side. They still ask you more than, which is on the right side. So hopefully you, even though they scramble it around, instead of ask you less to the left, right, more than to the right, in between, now they just ask you in between first, they do less than, and they ask you right then. But the concept, the idea is the same, right? So what is the story? What is the data here? The data is the average wait time. The average wait time for a drive-in window at a local bank is 9.1 minutes, with the standard deviation of 2.6 minutes. Assume that this is normally distributed. The reason why they give you this is they tell you that it's a bell-shaped curve. Find the probability that a customer will have to wait the given time when he or she arrive at the bank is between 4 minutes 97, 4.94 minutes and 14.04 minutes. So basically, again, this is what we have, right? We know that the average time waiting, the mean, That's what the average is. They change in the word, but it's the same, right? The average meaning the mean. If you come to the bank and you do the drive-through, right? The average waiting is 9.1 minutes. The standard deviation, the average difference from the mean is 2.6. And now they ask you, if you go to this bank, what is the probability, what is the percentage that you will have to wait between, let's say, 5 minutes and 14 minutes to be short, right? So in between, as you can see, you say, Mr. Trent, I got it. In between, let me sketch it out. And that's what I want you to do, right? In between, sketch it out, shaded in between. There's no sugar coating with in between, right? So between, this is the two number, but the small detour is we need to convert the z-score. We need to take the data, which is 4.94 minus the mean, which is the average 9.1, divided by the standard deviation, which is 2.6. Everybody see where my number came from? And then I have to do the same thing for 14.04. I take 14.04 minus the mean, which is 9.1, divided by the standard deviation, 2.6, and that is what I have. Once I have this thing here, what do I need to do? Well, I need to go to my table, and the table will be presented to you guys. We need to go to the table and extract out the 1.9 and the negative 1.6. And what do I need to do once I extract them out? Because I'm looking for in between, I need to look at the bigger area minus the smaller area. And I need to take this two area and find the difference between the two. And if I find the difference between the two, I will see the 0.9165, meaning the probability that a random person drive to the local bank and have to wait between 4.94 minutes and 14.04 minutes is 91%, roughly 92%. Right, the probability is 0.9165. Okay, so again, hopefully you guys see that it's very repetition, very consistently the same. The question, the data, the number are different, but the way that they ask you is the same. In chapter 11.7, we need to convert to the z-score in order for you to use the table. And again, I did not give you the table because I kind of run out of room. So that's why I just extract the z-score and the area out. It is the same. If you look at the table, it's the same number. Okay. Same thing go with B, right? We're looking for less than. We're looking for less than. What do we do? Well, anything less than is to the left. Right? Anything less than is to the left. So we know that to the left, life is good. How good? The answer is in the table. The only thing we need to do is we need to know what value from the table to extract out. Because if you go to the table, you don't have the 9.36, right? We need to convert this 9.36 minute to become a z-score. Because the minute is not in the z-score table. The only thing in the z-score table is the z. So we need to convert this. And if you convert this, you have 0.1. And if you go to the table, you see 0.1 is the same as 0.10. Then the area is 0.53. As you can see, my sketching is wrong, right? My sketching is not more than, if you look at this sketch, you say, Mr. Tran, your sketch is very sketchy, right? Again, it's wrong because my 50%, this thing here is more than 50%, meaning again, you're supposed to have something like this big, right? More than at least cover more than half, because half of this table is that. But like I mentioned, right, we don't really know. Alex won't ask you for your sketch, right? The sketch is for you to know what size of the value we're looking for, right? So the sketch, you just need to have an idea. If it's to the left, the answer from the table. If it's in between, we need to subtract among themselves. And if we're looking for an item on the right, then we need to take 1 minus the area. But before we take 1 minus the area, we need to know the z-score. And once we find the z-score, we need to take 1 minus this thing here. So as you can see, consistently, hopefully you guys see the consistency of this thing here. Consistently is the same concept, right? The information, the data present to you a little bit different, but we attack all of this problem the same way. Sketch your normal distribution. Tell yourself, do I looking for the area to the left, or in this case, the probability to the left? Or do I looking for the probability to the right? Or do I looking for the probability in between? So let me ask you guys question with this 3 problem here. Question with this 3 item that we have on the screen, how to attack this problem, or what are we looking for in terms of the answer? Any trouble here? Well, if you don't have question, if there is no trouble,